All right, one more time, I forgot to record that a lot of things in probability, you have two possibilities, win or lose, heads or tail, boy or girl, etc. Okay, you can read this slide, but we're moving on because we already talked about this. The essential elements in a binomial experiment are that they have to be independent trials. Okay, one cannot affect the outcome of the other. Each trial can only have two possible outcomes, whether that's success and failure, boy, girl, whatever you want it to be. The probability of success is the same for each trial, and the probability of failure is the complement of that. In other words, the basketball example said 70% chance of success, so the chance of failure was 1 minus 0.7 or 30% chance of failure. Everybody okay? All right, so then we talked through this example. If you're going to make 2 out of 3 free throws with a 70% chance, you could miss the first one, the middle one, or the last one. Each time the probability is actually the same, but there's 3 different ways it could happen for a total probability of 44% that you would make exactly 2 out of 3 if your shooting average was a 70%. Okay. Consider this number of outcomes. If you wanted 3 successes in 5 trials, okay, the number of ways you can succeed with 3 successes in 5, this is all the number of ways that could happen. I don't think we want to write that out every time, okay? Succeed, 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 fail, fail, etc. If there are 5 trials and we want to succeed 3 times, there's 10 different ways that could happen. Okay, so we're going to use combinations. In a binomial experiment, this is where it gets complicated, guys. You need to write this down or know that it's on page, anybody have their book open? 880 something. Anybody looking for me? All right, it says R is the number of successes in N trials, and your book is your calculator is going to use X here in a minute, but N is the number of trials, number of times you repeat the experiment, okay? You want 3 out of 5 of something. R is the number of successes you want. Okay? Your calculator is going to use X for that. So we're going to have a combination, and then the probability, P is the probability of success, and Q is the probability of failure, because it's 1 minus P. Does anybody find that page? It's on page 886. All right. This is kind of a complicated example, but it says a lottery consists of choosing a number from 0 to 999. All digits of the number must be matched in order. So the chance of winning is 1 out of 1,000. Does that seem okay to everybody? There's 1,000 numbers there. All right. Suppose you play 1,000 times in a row. We're supposed to write a probability distribution. So what's the probability that you win once? What's the probability that you win twice? What's the probability that you win 3 times? We're not going to do this out to 1,000 because pretty soon it's going to be 0. Okay. The probability that you win once is out of, are we playing it? We're playing 1,000 times in a row. Okay. So out of 1,000 trials, you're going to win once. What's our probability of success? 0.001. Sorry, I wrote that wrong. We're going to have 1 win. I forgot to start with 0 wins. We should have 0 wins. What's the chance of failure if our chance of success is 0.001? 0.999. And if we win once, we lose 999 times, okay? Boys, you do that one. Girls, I forgot to do 0. Can you do this one for me? Do out of 1,000, you win 0 times 0.001 to the 0 times 0.999 to the 1,000. This is, you're going to lose 1,000 times. This is going to win once. Anybody get some decimals on these yet?
I got one.
What do you have for the boys?
368,063.
Okay, that sounds like enough places. Girls, did anybody do this one? Okay. Now, what is it going to look like if you win twice? Can anybody figure out the pattern here? Out of 1,000, you're going to win twice. What would you type next? Probability of winning to the second times the probability of losing to the 998. Somebody type that one. And then the probability of winning 3 times. Right, anybody got the green one yet? Anybody do this one? Did somebody do the purple one? Yep, that's okay. Okay, so this is the chance that you win 0 times, 36.8. 1 time is about the same, okay? Just a little bit bigger. 2 times was 0.184, 18% of the time. 3 times was 0.06. They went ahead and made a chart, 0, 1, 2, 3. They went all the way out to 4. And then they said it's less than 1% after that. So they just subtracted all of these probabilities and said the remaining 0.0036 would be the chance that you win 5 or more times. Does that make sense? They didn't want to do a chart out to 1,000 wins, obviously, because pretty soon it's 0 anyway. All right. The second half of the question, guys. What is the probability that you will break even or better? How much does a ticket cost? $1. If we're playing 1,000 times, how much are we spending? Okay, so we're spending $1,000. How many times do we have to win then? The prize is $500, so we need to win 2 or more times, right? It says break even or better. So we have to win 2 or more times. Well, what was our chance of winning 2 times? Okay. It was this one, I think. 3 times was this, and so on. If we know the chance, please stop talking. The chance that we win 0 times was this, 1 time was this, okay? After that, we would break even or better. So if we did 1 minus 0.368 minus 0.3677, that would tell us what the chance that we break even or better is. Anybody do that? So that one took some thinking about what it meant to break even. Nobody's typing? Thank you. So the chance that we break even or better is about 26%. Not the worst lottery I ever heard of, right? All right, here's another example. And we're going to learn to do this on the calculator after this. It says Morgan is taking, and I don't mean typing them in the long way, okay? There's a shortcut on your calculator. Morgan is taking a 10-question multiple choice test. What is that telling us in our formula over here? N equals 10, okay? But hasn't studied. Each question has 4 possible responses. Anybody know what that's going to tell us? One of which is correct. So the probability of success is 1 out of 4, or 0.25. And Q, the probability of failure is what? Yep. Okay, find the probability that he answers 6 questions exactly right. Okay, anybody remember how that went? Here's the formula. Good, Sean. I hear you. 10C6, then what? Which is 0.25 to the 6th. And 0.75 to the what? Nope. How many do you have to get wrong to get exactly 6 right? Okay. This is you're getting right 6, wrong 4. Okay. You're multiplying all these. It should look like this. Are we good? 0.016? Half hour later? Okay. All right, guys, 4 or fewer questions correct. This is where it gets tricky. 4 or fewer right. So that means you get 4 right, or 3 right, or 2 right, or 1 right, or 0 right. Does this sound fun?
No.
We have to do this whole mess 5 times. Because this wins if we get 4, 3, 2, 1, or 0 right. Okay, there's a way. You could do it all. It looks like this. 10 get 0 right, 10 get 1 right, 10 get 2 right, 10 get 3 right, 10 get 4 right, and you add it all up. Okay? I'm going to show you a shortcut. 8 or more correct. Could we do that one by hand? That one's a little bit shorter. It'd be what? 8, 9, or 10 correct. Let's try it one more time by hand. 10C8 times 0.25 to the 8 times 0.75 to the what? Okay? Someone tell me what the next one would be if I wrote it out. 10C9, 0.25 to the 9th times 0.75 to the 1. Anybody do any of those? Did you get one, Vincent, or not yet? For the first one, or? 3.86 times 10 to the negative fourth. Okay. Times 10 to the negative fifth. Anybody do the last one? It's going to be even smaller. Okay. They added them all up and still had 0.0004. Does that make sense, guys? The chance that you guess and get a B or better on a 10-question multiple choice test? Pretty low, right? 4 choices. You know what? A lot of us don't guess randomly, right?
No,
You at least eliminate some. There you go. Okay, so it's very different than just randomly picking A, B, C, or D. Okay. We're gonna go. Let's go here and just do a couple, and then we'll come back and learn the calculator. Actually, let's just do the calculator, and then we'll come back. Okay. Here's the calculator. Shh, guys. On the calculator, there is a button that will calculate binomial probabilities. I need you to be paying attention because this is tricky. The ones that say exactly are not difficult. The ones that say more or less than are very confusing sometimes. Okay. It says Binom PDF is in the distribution menu of a Texas Instruments calculator. It will ask for R, and that is the number of successes. Okay. It will ask for P, the probability of success. And if you have an older calculator, if you looked in the handbook, it would say R, the number of successes. Our calculator says X. All right. So let's do the question we just did about 6 and 10 right. Yes. We're going to learn that one in a minute, and it's different. So please be very careful that you pick the right one. It's second, and then the vars key or the key right next to clear. You want to arrow up or down all the way to the one that says Binom PDF. PDF and CDF are very different. C is a cumulative probability. That's what we're going to use when it says like 3 or fewer wins or something like that. PDF means exactly. So we're going to pick PDF. Now, mine literally says trials. If you have an older one, you have to type it in with just commas in between. The first thing you type in is the number of trials, which was 10. And then if you have an older one, you do comma. Mine says P probability. That means probability of success. I forgot what our question was about. Oh, was the multiple choice. So it was 1 in 4, right? So 0.25 or 1 over 4. You can type a fraction or a decimal there. X is the number of successes. Okay. So didn't we do 6? Exactly 6 was one of them. So then I hit enter a couple times. And it comes out 0.016, which if I go back to this slide, right here, 0.016. Everybody okay or not? All right. CDF is much more complicated. There is also a command that says binomial CDF. This means the cumulative probability of R or fewer successes. If the question is worded that way, it's really easy. When the question is worded differently, it's more complicated. Okay? So if we want to get 4 or fewer successes, so what's the chance you get 4 or less right? So this time pick Binom CDF. Out of 10 questions, the probability of success is still 0.25, and what's the chance you get? Now, when you put a 4 here, because you did cumulative, it will do 4 or fewer, correct? .92, okay? And if we went back here, that was this question, probability getting 4 or fewer correct, 0.92. What are we going to have to do for 8 or more correct? Yes. 8 or more correct. Guys, are you listening? 8 or more correct. We need a fewer than. Can you rephrase that as a fewer than? This is 8 or more correct means we missed how many? 2 or less. Two or fewer wrong. Okay, what's the probability that we get something wrong? 0.75. Okay, so we want to say, out of 10 with a probability of getting it wrong of 0.75, we got 2 or fewer. So that's when it's going to look like. Try that one. Yeah, it probably will. Oops, I picked the wrong probability here. You can if you want. It is 2 or fewer, so it's CDF. 10, but this time we wanted okay, 0.0004. Is that what we had when we did this? Right here, 0.0004. Okay? So tell me one more time, why did we change to 0.75? Because we reworded the question from 8 or more correct to 2 or fewer wrong. So we had to do the probability of getting it wrong 2 or fewer times. Okay? Yes, yes. Okay. We are going to do some questions here. I'm not sure if you can see this.
I'm like 80% sure I was on that website the other day. I was actually.
Okay, what fraction, can we do this one on our calculator? What fraction represents the probability of obtaining exactly 8 heads in 10 tosses of a fair coin? Exactly means what? Exactly means we need PDF or CDF?
PDF.
Yes, exactly means binomial PDF. How many trials did the question say? 8 in 10. So trials is anybody doing this? Number of trials? 10. Chance of success when you flip a coin? And how many are we wanting? Okay, we get a decimal. If we do a math enter, is it small enough that it'll change it back or not? So I got the first choice here, 45 out of 10, 24, yes? Okay. Which is right. I'm got trouble with my smart ink here. Wait a minute. Really? It hates me. Okay, we're moving on. That is correct. Okay. Experience has shown that 1/200th, is everybody listening? 1/200th of all CDs produced by a certain machine are defective. If a quality control technician randomly tests 20 CDs, compute each of the following probabilities. Exactly one is defective. PDF or CDF? Exactly tells us that it is PDF. How many was he testing? If a control randomly tests 20 CDs, so he's picking out 20, and the machine has a history of 1 out of 200 being defective, so 1 divided by 200 is our probability of finding a defective one, and we want to find exactly how many? 1 defective one. So we get 0.0909, okay? Somebody write that answer down. We're going to check it in a minute. Half are defective. So exact same question, but what? 10 are defective out of the 20. That's going to be really small. Something times 10 to the negative 18th. We changed only the last thing from a 1 to a 10 because it's 10 out of 20. Did you get something times e to the negative 18th? Okay. No more than 2 are defective. Now wait a minute. Yes, we got to go to CDF. But no more than 2 means what? Okay, but wait a minute. No more than, isn't that the same as fewer? Yes. We're already at fewer. So it's 2 or fewer. No more than 2 means 2 or fewer. So we're going to put in a 2, but we got to be at CDF. We don't need to change the probability though. Yes. Out of 20, 1 divided by 200. We want 2 or fewer. Okay? It's 0.9998. Okay, so the first time, did we get 0.09? The second time, did we get a whole bunch of zeros and then 1/8? And the last time, here, it says 0.9998, which is what we got, right? So we got those all right. All right. You guys figure out this one. Oh, no, they didn't do that one as a decimal. We'll skip it. Okay, I thought this was an interesting question. After studying a couple's family history, a doctor determines the probability of any child born to this couple will have a gene for disease X 1 out of 4 times. So probability of getting this is 1 out of 4. Everybody good? If the couple has 3 children, what is the probability that exactly 2 of them will have this? 2 out of 3 children. If it's exactly 2, it would be what? PDF.
So 3 children. 2.
3 children, yep, 1 out of 4. And exactly 2 of them have this would be? Okay. 14% chance that 2 of their kids would get it. Would carry this gene. What is a question you would ask yourself if you were these parents? What's the chance? How many kids do you want?
2. I want 2 kids.
Okay, if you went with 2 kids, okay, What's the chance that both of them are okay?
What if I did like,
So, do the question.
what are we talking instead of X value for that one? 18 kids in county?
The one we just did or the one we're doing now?
We just did. What was the X value for that one? 18 kids in county?
2, because it was 2 out of 3 kids.
So the trials are 3, right?
Yes?
1/4 is.
Yes. Okay, so if we had 2 kids and the chance is 1/4, what is the chance that none of them will have this, carry this gene is 56%.
I keep on getting point negative for,
No, because
Yeah, you can
they're
add
so
it up.
recessive.
It's over, like, drop it.
Did you figure out what you're doing yet or not?
never mind, I was in CU.
Okay. And I think I just did this one wrong because I think I was in the wrong thing. Out of 2 kids, 0.25, 0. Well, the chance that one of your 2 kids has it is only 9%, so it's... All right, moving on. Let's try this one. On any given day, the probability the entire Watson family eats dinner together is 2/5. Find the probability that during any 7-day period, the Watsons each eat dinner together at least 6 times. That's supposed to be eat dinner together at least 6 times. At least 6. We will do the bowling one. I like that one too. At least 6 times. At least 6. Does that mean 6 or fewer? Means 6 or more. So out of 7 days, that would mean what? 1 or fewer times they don't all eat, right? Okay, I'm going to read the question to you again. On any given day, the probability the entire Watson family eats dinner together is 2/5. Find the probability that during any 7-day period, the Watsons eat dinner together at least 6 times. So at least 6 times means they don't eat dinner together, 1 or fewer. Okay? So what's the chance they don't eat dinner together if it's 2 out of 5 that they do? We need CDF, 7 days. If the chance they eat together is 2 out of 5, the chance they don't is 3 out of 5. And we want them to not eat together 1 or fewer times. Why do I have an extra? Do I have something weird? I just have a parenthesis in here somehow. Did anybody get .018? Okay. That's what they have, .018. All right, last question. Let's try this bowling one, guys. I would like to do the bowling question if you will be quiet.
Guys, quiet down, please. Come on.
When Joe bowls, he can get a strike 60% of the time. How many times more likely is it for Joe to bowl at least 3 strikes out of 4 as it is for him to bowl 0 strikes out of 4? We'll get to that part, but let's figure out what's the chance that he gets 3 strikes out of 4? His chance of success is 60%. At least 3 out of 4. So he does not get a strike one or fewer times, yes? Okay, so we need a CDF. Yes, 4 trials, good. Now be careful. We're doing that he doesn't. So 0.4, no. We're, the chance that he, at least 3 is 1 or less that he doesn't, so we're gonna go with 1. Okay, so I got 475, yes? Okay. It says, what is the chance that he gets 0 strikes? 0 strikes out of 4 tries.
Was that a PDF or a CD?
His chance of getting a strike, we want him to get 0.
So is that probably a 0.4?
It doesn't actually matter, but 0.6 would be. Okay, so now what do we need to do? The question says how many times as likely, so we need to take that first answer and divide it by the second. And we got almost 19 times as likely. Is that the right, round to the nearest answer would be 19. Their answer is 19 times more likely. Okay? All right, your assignment on this section. We do. There's not very many of these kind of questions, like 1. I don't think this section is on the final, no. Okay. This assignment is, guys, it sounds like a lot of questions, but it's really not, because if you look at this first one, it says the probability of success is 0.65, so what is the probability of failure? 1 minus 0.65, which is 0.35, okay? So all of the questions aren't the same. They're not all calculator questions as far as PDF or CDF. It's page 889, 1 through 3, 5 through 7, and 9 through 12. Okay? When did I stop recording?